So we shall continue the discussion which we were having just in the last lecture from the same point where we had stopped, that a signal is very easy and convenient to be understood when it is a discrete signal, sample signal or digital signal. The difference between discrete and digital is not to be required to be known in detail because of the approximation is very clear. Approximation is just negligible. So what we means in general, instead what has happened that the subject signals and system was having very complex phenomenon earlier when there was no question of this discrete and digital realizations. But when these discrete and digital realizations became easy or became very quite possible, it was proliferated to many to such an extent that it is obviously understood by anybody. There is a new phenomenon by which understanding of systems is more easy in discrete domain than in continuous domain, because in continuous domain we have to understand convolution, which is an integration process which is complex. So numerical computation methods were there, but with such discretization, such sampling and digital things coming into picture, things are quite clear. Therefore it's a new pedagogical technique, it's a new way with which the student should be explained the working of some concept, that the actual system is real-time physical system. Say input voltage coming from somewhere, resistor, capacitor, output voltage is available. So everything is available in continuous form. The things are happening continuously. The components are physical components like resistor and capacitor. Then instead of understanding its working by solving a differential equation into a solution which contains an integration term, convolution of input and some system function, instead of that, it is more convenient to understand its working not by writing a differential equation but by writing a difference equation and by approximating the concept of derivative function as current sample minus previous sample upon sampling interval. And when our sampling interval is negligibly small, the results which we obtain are as good as accurate, or rather more easy, just like the picture you take using digital camera and the picture which you now take using conventional non-digital camera. Even though conventional non-digital camera is having infinite resolution, the resolution which we get on digital camera is so fine that your eyes cannot see beyond it. Means the discrete, continuous things arranged one after other are to be viewed by human eye, and human eye automatically makes it continuous. Therefore, it is just like that analog camera is as good as obsolete. Analog camera which actually captures the image on some photo film with infinite resolution is as good as obsolete. Like that, in teaching learning process also, understanding the differential equations has become somewhat written, not exactly. It is not like a analog camera or normal conventional camera, non-digital camera becoming obsolete. It's not a differential equation have become obsolete, but these are redundant. These can be put on back burner, and it is possible that signals and system subject working of all such systems can be learned without going into complex details of differential equation. The problem is that once we are entering into complex properties of differential equation, we are unable to understand that, and that creates a bottleneck in understanding. Then this difference equation is a tool. Difference equation is a tool to understand the actual process wherein there is not direct relationship between output and input, but it is in differential form. When there was resistor only, VOT was something into VNT, but the moment at which capacitor comes into picture, in that situation, what happens is, for simple RC circuit, the equation which governs the relationship between input and output voltage, V in T and VOT, is not direct but is in differential form, where differentiation of output dVOT by dt plus VOT is equal to V in T. Therefore, I again repeat, wherever in your circuit, in your system, components like capacitor, similar components are there in mechanical systems like spring. There are different components. Even what we can say, we had taken a simple example that is most important example, which I will repeat again, to illustrate the simple process. Of what a system is, and while explaining that example, I will deliberately take further complex system so that you should get an idea of what is a system. So let it be made very clear that signals and systems has nothing to do with electronics. It is a general purpose subject applicable for all disciplines of engineering, and it studies the relationship between input and output, some input signal, some system, and it is producing output. So I am once again taking the example of our water tank model. So I will make you to prepare a complex differential equation, and I will make you to prepare to solve that, and we will also prepare difference equation. You will solve that. So in today's session, after today's session, you would be in a position, in a new terminology, there is outcome and objective, all that. So the outcome after today's lecture is that you will be able to construct the relationship between input and output and solve it so as to obtain output from input. So we take one more simple example again, that we have a valve. This valve has got an opening, that is an opening which will give you an opposition. We will have a tank. It is a very famous example. Now I will change the dimension of the tank in a very interesting manner, that also you will understand very easily after we introduce. But I will first make you to learn that the tank is having cross-sectional area A. The level of, and I am deliberately taking the example of water level, which is more easy to understand and imagine than voltage. It is more easier to understand voltage because there is likelihood that I am unable to understand, even though I tried my level best to explain in circuit theory, resistance, capacitance relationship, one may not have understood. Let us forget it. Let us not make it a precondition to understand signals and system. So it is, signals and system is a phenomenon between one signal called input signal. The signal is level, water. So one more example of signal. Water level at various points in an hydraulic system. Water level at various points in hydraulic system is a signal, L bracket T, where L is in length, meters, with reference to some reference, ground reference level, common level. What is ground? what is earth, what is neutral. On that I will have one more extra session which you can watch at a leisure time. So right now let us focus on the water level model. Now we consider it as a system. Signal is water level and system is wall tank. Signals and system. If you go through syllabus, there will be some definitions of that. I am not going into those things at the beginning. At the beginning, in the first week, you should be able to have a complete bird's overview of what the subject is and try to get some details of the overall subject, not any point as such. So signal is here water level, input water level and output water level, and system is our valve and tank. That's all. Signal, water level, system, valve and tank. So valve, tank. Valve has got parameters, some opening leading to a position O. Tank is having some cross-section area A. And here there is our magic system. This is reference. This is the input tank. It has got an outlet. And a municipal water is continuously entering in. We keep at some height. A municipal water is continuously entering in, and this is fixed. So it is resting on one platform. So this is say 1 meter. So here water level L in T is 1 meter constant. L in T is 1 meter constant. Valve is having opening O, opening leading to opposition O, cross section area A. We know the equation of flow. This is LOT. So flow at any given point of time is level difference between input and output, L in T minus LOT upon opposition O. More the opening, less the opposition, less the opening, more the opposition. So this is one equation which is governing things. This equation, for those who have observed the first lecture in the circuit theory, for them it may be repetition, but many might not have observed it neatly, many might have ignored, many might have forgotten. So for them it is overall revision, but what I am doing now, I am not keeping it simple, I am making it change now. So what I will do, so continuous water is flowing in this tank. Continuous water is flowing in this tank. This tank is having one switch, that is stopper. It is open at some time, at t equal to 5 I open it. So once it is open, it is always open. Now there is no need of closing. Now what I will do, this arrangement L in T is on a fixed platform. Now I will make it change. Are you getting me? This is the left hand side tank. This is my reference level 0. It is, this tank is having 1 meter height, means from this opening, this is 1 meter. So water coming from municipality, corporation is sufficiently available so that excess is drained out. So this level is maintained always. This is 1 meter above this base. But now I will vary the base. So what I am doing, L in T I am not keeping constant. I will put L in T on some kind of piston. You may be knowing the various arrangements where piston is there. If you go to a grinding mill where you are having some kind of piston, piston is there. So what the piston does? The piston is having a movement like simple harmonic motion. So position of the piston is moving with reference to some base in a sinusoidal manner. So L in T, what I will do, L in T this is one max position, I can bring it down so that L in T will become 0. Then I will make it up. So what is the theme is right now, in what way I change is not important. We will be giving some examples to that also. What is important to be understood right now is that this base on which the left hand and this pipe is very long, so that there is no question of when we say the pipe will break, it will not break. So the left hand side tank to which municipal water is coming and a fixed drain is allowed, this level L in T, when this was fixed it was 1 meter, but now L in T I can vary. So L in T is now no longer a constant thing. If it is so, then the simple question is, a step for a system which is having a valve positioned at such stage where opposition is O, a tank which is there which has a cross-sectional area A, derive the expression between, and input is changed, means you can change input in any manner. So the question is, establish the relationship between V in T and VOT. L in T and LOT. Is the idea clear? On the left hand side there is a tank to which opening is there, municipal water is always coming, so that this water column will always be full up to this level. What you do, you change it like this. So whenever you change it, this level will come down, this level. So with reference to this, LIT would be up to 1, up to 0. So it will change between 0 to 1 when you move the base like this. So L in T can be changed. You can bring it negative also. You can bring it down. There is no harm. So L in, with reference to this base level, which we define as 0 level, L in T is a function of time which you desire. So input signal, it is you who are going to give to system. So if such an input signal is given, what will be the output in the tank? Seeking excuse from those who may not be able to understand Marathi. In order to make the thing simpler, I would seek permission to utter few sentences in Marathi. Valve आहे, हा एक टँक आहे, ह्या साइडला एक टँक आहे, इथे ओपनिंग आहे, म्युनिसिपल वॉटर इथं कंटिन्युअसली येत राहते, हे फिक्स ड्रेन असल्यामुळे ही लेवल मेंटेन राहील. हा जो डायव्हर्टरचा टँक आहे, हा आपण एका बेस हे टेबल आहे, त्या टेबलवर ठेवलेला आहे. हे टेबल आहे, टेबलवर ठेवला आहे, पण हे टेबल फिक्स नाही आहे. हे टेबल मी हलवू शकतो. मग जर मी आता टेबल हलवायला सुरुवात केली तर L in T जे पूर्वी म्हणजे मागच्या सेमिस्टर जेव्हा आपण एक्झाम घेतलं तेव्हा 1 मीटर होतं, आता L in T = 1 मीटर नाही. मागच्या सेमिस्टरला आपण L in T घेतलं तर पण पुढे घेतलं नव्हतं, कारण का आपण L in T = 1 होतं. आता L in T = 1 हे नाही, कारण L in T मी आता बदल हे टेबल जेव्हा फिक्स होतं तेव्हा L in T 1 होतं, हे टेबल मी आता पुढे भाग करणार आहे, वर खाली करणार आहे. सो L in T नाव इज इनपुट सिग्नल. वॉलचं ओपनिंग ओ आहे, जिथं अपोजिशन म्हणजे वॉल कमी ओपन जास्त ओपन, वॉलच्या ओपनिंग प्रमाणे फ्लो कसा असेल, L in T - LOT upon O हा फ्लो असेल. वॉलचं अपोजिशन O आहे आणि उजवीकडे टँकचा क्रॉस सेक्शनल एरिया A आहे, उजवीकडे टँकचा क्रॉस सेक्शनल एरिया A आहे. सो जर उजवीकडचा टँक ज्याचा क्रॉस सेक्शनल एरिया A आहे असा कंटिन्युअस लॉन्ग सिलेंड्रिकल टँक आहे, वॉल एका पोझिशनला ठेवलेला आहे. वॉलची पोझिशन अशी आहे की त्याचा अपोजिशन O आहे. अपोजिशन म्हणजे लेवल, अपोजिशन म्हणजे काय, लेवल अपॉन फ्लोचा रेशो, किंवा फ्लो म्हणजे लेवल डिफरन्स अपॉन अपोजिशन. सो अपोजिशन O असेल, क्रॉस सेक्शन एरिया A असेल, O एक कॉन्स्टंट आहे, A एक कॉन्स्टंट आहे. तर अशा सिस्टीम मध्ये L in T आणि LOT ह्याच्यातलं रिलेशन काढायचं आहे. We have to establish relation between L in T and LOT. We will establish differential relationship. Then we will be changing to difference relationship. And this is a study of signal and system. So signal is input signal, L in T, output. So for a system, I will give in L in T, I will give L in T constant, I will give L in T square wave, I will give L in T triangular wave, I will give L in T exponential signal, I will give L in T a sinusoidal wave. What will be LOT for this O and this A, and then what I am going to do, I am going to change this tank also. So today I would be able to introduce to you to different systems and make you to think how they work. Now what will happen now for this scenario? I will just reduce the space so that we would be getting the board area for writing the equations. So a position is O, this is the wall, this is the tank. This is the output level, LOT. A position O. Now, those who might not have given attention in the first semester, those who might have somehow skipped the contents, should try to listen very carefully, because this is a very important question of a system. Signals and system, let us be very much attentive for every minute. Okay, so now this is the valve. This is the valve. Valve is like a resistor and tank is like capacitor. So this is a series circuit. So the connection between valve and tank, it is joined. So whatever is flow from the valve, same should be flow into the tank. There is no leakage outside. There is no leakage outside. So for a series circuit, resistance current and capacitor current are same. Likewise for this arrangement, flow from the valve and flow into the tank must be same. What is flow from the valve? Flow from the valve is flow T, Ft is equal to L in T minus LOT upon O. Flow from the valve is on right hand side, L in T minus LOT upon O. It can be reversed also if I change it. In that case, the value will be negative. Now, as regards to tank is concerned, what is the relationship between LOT and flow as regards to tank? Now, listen very carefully. In the first semester, you might have listened hurriedly. Now, try to understand very clearly what is the relationship between flow and tank level. Now, level in the tank. What is the quantity of water in the tank? It is a cylindrical tank. I am taking simple thing. It is a cylindrical tank. So for a cylindrical tank, what is going to happen is that the quantity of water in the cylindrical tank, if I define it by a new variable called as WT, as it is water, I use W, that is quantity of water in the tank is equal to area into LOT. I think it is very simple. Volume of the cylinder is equal to cross-sectional area into height. The cylindrical tank, if it is filled up to level LOT, it will contain water. WT is equal to A into LOT. Therefore, we can use this. Now, what is flow and quantity relationship? It's most important question. Now, this is the way the various physical entities, like in case of electrical circuit, capacitor, in case of hydraulics, tank, they establish differential nature relationship. The capacitor stores the charge and differentiation of charge is current. Tank stores the water and differentiation of water quantity is flow. So what will happen? What is flow? That Ft is entering from this to this. Ft is entering from this to this. So what is happening? There will be rise of level in the tank. So flow in the tank will be what? Flow in the tank will give rise to increase in level, or the water flow. Listen very carefully, I am explaining it in extremely simple language. The flow in the, because of this valve, for what is relationship for a valve? A valve, depending upon its opening and opposition, the flow in the wall is like resistor. For resistor, the current is voltage on one end minus voltage on other end upon R. Like that, for a wall, the flow is level on one side minus level on other side upon O. So this is flow. Now when this same flow comes here, we want to establish relationship between flow and level. Flow and LOT. How we will be able to establish relationship? So suppose, listen very carefully, this flow FT, if it occurs for infinitesimally small time delta t, flow need not be constant always. Right now, what Ft? It occurs for infinitesimally small time delta t, then how much quantity of water will be added in the tank? How much quantity of water will be added in the tank? The quantity of water added in the tank will be Ft into delta t, because flow is water quantity upon time. So quantity is flow into infinitesimally small time. So because flow is assumed to be constant in that small period, flow is not otherwise constant. So flow Ft into infinitesimally small time interval delta t. So in a small time interval of delta t, from right now I am at time t, I go from t to t plus delta t, or from t minus delta t to t. Both are same, not much difference. There is no need to consider that much when we consider differential equation. So between t to t plus delta t, Ft delta t water will be added. Ft delta t water will be added. So if level is LOT now and LOT plus delta t later on, what is the difference between these two levels? Difference in quantities is Ft delta t. Difference in quantities is Ft into delta t. So when this much water gets added, if initially level was LOT, after this much water gets added, what would be LOT plus delta t? LOT plus delta t is equal to LOT plus delta L plus delta L. So delta L is the water level rise in the time slot delta t. In time slot delta t, water quantity rise is this and water level rise is this. So what is this? Water quantity rise. Water quantity rise means it is delta W. Delta W. So delta W is Ft delta T. What is delta L then? What is delta L? Relation between W and L is such that W, or instead of delta LO you can have, because it is O. W is equal to A into LO. A is constant, therefore, or in general, WT is equal to A into LOT. So A is constant, therefore delta W is equal to A into delta L. So delta L is equal to delta W upon A. So this is equal to LOT plus delta L is delta W upon A. So listen very carefully, need attention to each and every step, because it is study of a system. So LOT plus delta T is equal to LOT plus delta W. What is delta W? Ft delta T. Ft delta T upon Is it understood now? This is the most significant equation. The rise in level of the right hand side tank in the small time window of delta t is governed by this equation. Now if I take this on this, if I take this on this side and swap the sides, I think it is very easy. So Ft delta t upon A is equal to LO T plus delta T minus LOT. Is it right? There is no new invention, just rearrangement of the terms. It's just rearrangement of the terms. Then, if I multiply this, only keep Ft on this side is equal to A goes here, and a very familiar term LO T plus delta T minus LOT upon delta T, and as delta T tends to 0, the right hand side bracket term is nothing but dLOT by dt. So Ft is equal to A into dLOT by dt. And since it is a series circuit, since it is a fixed arrangement, no leakage, both must be equal. So A dLOT upon dt is equal to L in T minus LOT T minus LOT upon O. Multiplying O on the other side, what we get? Multiplying O on the other side, OA dLOT upon dt is equal OA dLOT upon dt, this you can take on the other side again, plus LOT is equal to L in T. That is the differential equation, which is very similar to RC circuit. And if I choose my O and A such that O into A is not necessarily, but for simplicity, O into A is equal to 1, then this is my differential equation. dLOT by dt plus LOT is equal to L in T. dLOT by dt plus LOT is equal to L in T. And then this you can solve using initial condition and get an expression. But the same, so this is what is required is by all means you must establish this equation first, that is this is system equation. And once the system equation is there, we can solve it by using discrete techniques, that is a completely different part of the story. So what is important is to be able, for any given system, input signal is there, output signal is there, you must be able to establish the input-output relationship. You must be able to establish input-output relationship, and once you are able to establish input-output relationship, you get an equation which governs the input and output very appropriately, and then we can develop this equation and we can solve it by using numerical techniques, by using differentiation equation. So that is very simple. Now I will explain you a new method wherein instead of this now fixed base width tank, now I will make the tank a conical tank. I deliberately want to make this system, make the things difficult for you so as to give rise to your thinking abilities. Now I will make the tank as conical tank. So the tank, we can make it different kinds of cones. Conical tank, inverted cone or normal cone. Inverted, we can make it normal cone like this, say. So the right hand side tank is now a conical tank. When we say conical tank, in conical tank there is a ratio. This is the angle and this is height, radius and height. So we can have various angles also. For simplicity, we will make the tank as this angle as right angle, or RH ratio we deliberately keep as 1. This is the tank. So what will happen? Initially the water may rise fast, but as now, as is the tank, for previous cylindrical tank, what is difference now? W was A into LOT, or at any given point of time, when if the cylindrical tank is filled up to LOT, the water contained there is equal to WOT is equal to A into LOT. WOT is equal to A into LOT. Now this was for cylindrical tank. Now everything rest is same. Wall is same. This LNT, this tank is same. What is different now? The different now is this. So this was for cylindrical tank. Now we have to establish this relationship for this conical tank. This conical tank like this, and there will be reverse cone also. We will explain both for both because it is study of system. Signals and system, the valve and conical tank is a system. It's a different system than previous system. So for conical tank, establish relationship between WT and LOT. It is not so easy. Those who want to attempt on their own should put a pause button now. What is the question? As for a conical tank shown in the figure where RH ratio is 1. So this angle is 45. So for RH ratio is 1, establish relationship between W and LOT. WT and LOT. How the relationship will be established? Now those who want to attempt should put a pause, calculate, and when they either finish calculation or conclude that they are unable to calculate, press resume and they can view. So now let us proceed further. What is, let us say that LOT. What is the formula for the volume of a cone? Formula for volume of a cone is, we are having the height of the cone and base width. We are having height of the cone and base width. Based on that, we have what? Formula of volume of a simple cone. This is simple cone. The height is LO T. This is also LOT. Because I have taken this angle to 45. If the cone angle is different, then the method of formula is different. So in this case, it is what? Since both are same, it is based on 1/3 h r square. It is 1/3 h r square, or it is said as 1/3 r square h. 1/3 r square h is the formula. So now here, since h and r are equal, this and this are equal, we can say 1/3 h cube. Volume is 1/3 h cube. Volume is 1/3 h cube. So the quantity in the tank is proportional to the cube of the level. So cubical relationship is there. Even if this angle is different, there also cubical relationship. Only thing is that this 1/3 will not be there. So we will explain it at a later time when its turn comes. So right now, for this simple tank, for this simple conical tank with the RH ratio to be 1 with this angle to 45, WT is equal to 1/3. WT is 1/3 LOT cube. WT is 1/3 LOT. So now we will say, in previous example you are given cross sectional area A. Here you are not given cross sectional area. There is no need. The cone is of infinite height, so that area need not be given. What is given is HR ratio is 1. So this is a cone. When a cone is given with the cross sectional angle as 90, that entire description of the cone is over. There is no need for, and it goes till infinity. So there is no need to give anything more. So the cone is completely described, and for that cone, the relationship between WT is equal to 1/3 LOT cube. So this is W. Now what is happening? What is the relationship between differential relationship? So this is very clear. WT is equal to 1/3 into LOT cube. So as the level rises, the quantity will rise in cubical proportion. In case of cylindrical tank, it was rising in direct proportion. A was fixed, it was rising in direct proportion. Then you can have a spherical tank, you can have a inverted conical tank, you can have a random tank. So in general, what is important is, now we are not studying hydraulics. What is important is, we can have different kinds of structures for which a different structure means what? A different relationship between WT and LOT. In previous tank it was linear. Now, so this is some constant, there is no immaterial. So this is something I can say C1 into direct. So here it is C2 into LOT cube. Directly I want to cube. Then can you think of some such structure where the relationship would be square? Something in between cylinder and cone. Something in between cylinder and cone. You can think of such structure. You can think of such structure for which WT would be proportional to LOT square. That is homework for you. So now for this particular equation, what is the final equation governing V in T and VOT? That is a very important task, and listen very carefully. I will try my level best to explain. I am using the board space. I am showing this LOT on the left hand side. So I use the complete space here. So what is flow? Flow T, that equation is fixed. It is L in T minus LOT upon opposite O. That is equation 1. And now in time delta T, what is quantity added? WT, that is the added quantity, or delta WT we can say. Delta WT, or there is no need for you to have WT. What we can have? Delta W, that is the quantity added in the output tank, is equal to FT into delta T. That is also fixed. FT into delta T, that is also fixed. Now the question is, the delta W water will give rise to how much difference in level? So what is this? Delta W is equal, what is the Wt plus delta T minus Wt is equal to delta W. That is Ft delta T is equal to Wt plus delta T. It is what? Wt plus delta T is equal to 1/3 LOT plus delta T cube minus 1/3 LOT cube. So this is something which is making the things not so easy. So 1/3 is common. 1/3 into bracket LOT plus delta T cube minus LOT cube is equal to Ft delta T. Ft delta T. So now, how will we proceed further? How will we proceed further? How will we expand this term? So here the relationship between, now we can explain it in simple manner, but there is a more easy method. W is equal to 1/3 or Wt, we can have Wt is equal to 1/3 LOT cube. Now, or we can write down more simple way, LOT cube is equal to 3Wt. LOT cube is equal to 3Wt. Now differentiating it with respect to time, I get 3D. Now how I will differentiate? If I differentiate it with respect to time, then what I will get? If I or what I get, there is one more method. What I get, LOT is equal to 3Wt raised to 1/3. 3Wt raised to 1/3. Wt is equal to 3, LOT is equal to 3Wt raised to 1/3. Then next, if I now differentiate with respect to time, so what I will get? dLOT by dt is equal to 1/3 will come out. This 3 will come out first. So this is this 3, I will say 3 raised to 1/3 into Wt raised to 1/3. So 3 raised to 1/3 will come out into 1/3 Wt square dWt by dt. dLOT by dt. It is not so easy. Just so what I wanted to convey. I wanted to convey that a step in previous case when the tank was cylindrical, we could establish the relationship very easily. That dLOT by dt plus LOT is equal to LIT. Now what is happening? The flow is remaining same. In delta t time, Ft delta t water will be getting added, but water Ft delta t getting added in the tank is giving rise to how much water level rise. So that is not a constant relationship. That depends on water level also. Suppose if initially if I put 10 ml of water, the level difference may be large, but when it is tank is much full, the 10 ml will be giving rise to small level difference. So try to establish the very peculiar differential relationship between water quantity and water level. So the water is cube of level. Water is cube of level. So Wt is equal to 1/3 LOT cube. So there are various ways. Either you can go by this way or you can go by other way around. dWt upon dt, that is the change in quantity, is equal to, that 3 will come, 1/3 and 3 will go, would be LOT square dLOT by dt. LOT square dLOT by dt. So that also you can put. So the quantity added is delta W in time delta t. So in time delta t the quantity added would be, so you can approximate this equation also. There is alternative method. I will give you as a homework to come up with a perfect method. So if this is derivative, then in time delta t the quantity added would be just multiplied on the other side. So delta W is equal so when we write differential equation for some approximate, this is this. So this is approximately equal to delta W upon delta T. So delta W upon delta T is this. So delta W is equal to delta T into this now. LOT square into dLOT by dt. So that is, I think it is enough here. So that is delta W. So what is delta W? Ft delta T. What is Ft? Ft is this. So we write the final equation here. I hope that you need to watch it once again by stepping through and stopping wherever required. So what we get here is that delta W is this, delta W is this, Ft is this. So delta W, Ft, what is Ft? Ft is this. Ft is this, that is L in T minus LOT upon O is Ft into delta T. Is that so? What is delta W? Delta W is Ft into delta T. What is Ft? Ft is L in T minus LOT upon, that is fixed, into delta T is this. This is equal to this delta W, that is delta T into bracket LOT square into dLOT by dt. So see what complex expression it is, just a simple system. So delta T